Hi, everybody. We're doing the last section in the polynomials, which is Z7, multiplying two polynomials using algebra tiles. Algebra tiles are specifically made for this. This is what they were for. We put them together usually in a rectangle, and we are supposed to represent binomial or polynomial multiplication. So the trick is just to be able to read what you see there. So if you look at the dimensions of this first rectangle, you can see, hopefully, I'm just going to I'm going to write the dimensions for every one of these rectangles so that you can see what I'm talking about. If I touch them, they're gonna disappear and I'm going to get it wrong. So we've got this rectangle here. Sorry, it's going to be a little off, but hopefully I can show you what I'm doing here. And what I'm going to do is I'm just going to put the model in the first time, and then after that I'm not going to put it in anymore. I'm just going to write the dimensions for you. So here's my model. There we go. Okay. So I can't write on the one over there very easily. So what I want to point out is that this is the x's here, these green x's, and they have a length of x by 1. And this one has a length of x, and this one has a length of x. And this is 1 because that's its width. And its area is x because 1 times x is x. So that's what's really going on with those green rectangles. Basically, they look like this, and they are 1 by x, which gives them an area of x green units. The 1 by 1 units have an area of 1, of course. And the x squared units clearly have an area of x squared. Hopefully all that's clear. 1 by 1 is 1, x by x is x squared. And if we look at this, we have 6x squared plus 1, 2, 3, 4, 5, 6, 7, 8 x's plus 2. But what we want to see is what are the dimensions of this thing? Well, this is 1 and x and x. And if you see this, this is 3x plus 1 by 2x plus 2, which are the dimensions of this rectangle. So it is the first one. But let's go ahead and take a look at the other ones and see what dimensions they have. This one has the dimensions this way. See if you can predict it. It's 3x, there's 1, 2, 3x plus this 1. And this way, we've got an x plus 1, don't we? And so that's the model that's being presented there for that one. Now, if we look at this next one, can you see it better now? Hopefully you can read it. We've got 2x plus 1. Here it is. And over there, we've got 3x plus 2, don't we? It's really close to the other one. And this last one, this one is 2x plus 1. And the bottom face is 2x plus 2. So hopefully that makes sense to you guys. That first one is the one we were looking for. It's right here. And we could multiply it out to see if it's true. And a really good idea is to be able to multiply your binomials in your head. So we get 6x squared plus 8x plus 2. And sure enough, that's what this one says right here. Okay, so now we just have to read them. So this one says 3x plus 2 by x plus 3, doesn't it? That's what this says down here. But it also says the same thing on the top. So we're looking at x plus 3 times 3x plus 2. There it is right there. And this one is 3x plus 3 is probably easier to see along the bottom here. This 3x plus 3, I don't want to accidentally touch it. Along the bottom is easier to see than in the top, but it's still, this is still x by x, and you still have an x and x and x and a 1 and a 1 and a 1, which is still 3x plus 3. And we have an x and an x and a 1 and a 1 and a 1, which gives us 2x plus 3. So we're and hopefully you can see that that 3 by 3 makes this 9 right here, doesn't it? And you see this 3 by 2x gives you 6x. And this 3 by, the 3x is 9x. And this the 6x squared, isn't it? Hopefully all this makes sense and you can see the pattern better. Let's see, we're looking for 3x plus 3 times 2x plus 3, and there it is. Okay, I'm going to go a little faster. These are pretty cool to put together. It takes a little practice to put them together. This one's almost right. It's only 3x plus 2, though, so that's not it. This one is definitely x plus 1 by 2x plus 2. This one is x plus 1 by 3x plus 3, and there it is. This is the one we want, not that one, not that one. This last one is x plus 1 times 2x plus 3, which is not it. We want this one right here. Okay, I said I was going to go faster. I'm going to go faster this time. So I've got 3x plus 2 and 2x plus 3. So I'll write it right there. Hopefully you can read it. Not sure if you can read that or not. It's easy to make a mistake. You got to be careful where you're looking there. Well, that looks like it. Okay, we're looking at an x plus 2 by 3x plus 3, and there it is. It's the very first one I see. I can see the x plus 2 and 3x plus 3. There it is. Like I said, I'll go a little faster. Okay, we've got a 2x plus 3 over here and an x plus 2 the other way. So x plus 2 times 2x plus 3. There it is. This one. Now, if you're having trouble reading these, just remember, you're just looking at distances. The green x's are x long and x long, and there's a 1 and a 1 and a 1. That is 2x plus 3 and 2x plus 1, isn't it? Oh, they gave me the first one, didn't they? There it is. Got to be careful writing on those. All right. Use the model to find 2x plus 1 times 2x plus 1. Oh, okay. So this time, rather than multiplying by FOIL or multiply by using the pattern, hopefully you'll recognize this as a perfect square trinomial. And remember, perfect square trinomials are you square the firsts, 4x squared. You multiply the factors together, and they end up getting doubled. The 2x plus the 2x is 4x. And of course the plus 1 at the end. But you can literally read it off of the model. This is 4x squared, isn't it? Plus 4x plus 1. There it is. We're just supposed to learn that there is a connection there. So we're supposed to use the model 3x squared plus 4x plus 1. And there it is. I kind of like to look at these and just make sure that I add my middle terms, because the firsts are pretty easy to multiply. X times 3x is 3x squared. And the lasts are pretty easy to multiply. That's going to be the 1 times 1. But it's the middle ones that you want to add in your head, the 3x plus 1x, which is 4x. And of course, here's the visual of it. All right. Okay, we're supposed to multiply them together. I'm going to go ahead. I can count them, which is 10x, 4x squared plus 10x plus 6. Almost grabbed that one. There it is over here. But of course, it's good practice to multiply it the other way as well. not only just reading it, of course, that's always nice, but this is 4x squared. 4x and 6x makes 10x plus the 6. There it is. It's important that you learn to multiply these in your head, okay? Trust me. See, 3x and 9x makes 12x for the middle term, doesn't it? And we know we get a 3x squared plus 9 on the ends, and so there it is. And of course, you can count them if you want. We've got a 6x squared, we've got a plus 6, and our middle terms are 6x and 6x. Are they? Yep, they sure are, which is 12x. And yep, we got 6 and 6 and a 6 and a 6. Yeah, there it is. Okay, we've got a, oh my God, I said okay again. All right, 5x in the middle and a 3 at the end, and there it is. And I'm just going to check it by actually counting them. I'm actually going to do the exercise, which is to count all the parts. 3x squared plus 5x plus 2. Oh, maybe we're supposed to write it this time. Oh, there we are. We're supposed to write it down. So we've got 3x squared. I'm just going to multiply it up here. Oh, no, there it is. 3x squared plus 5x plus 2. I'm actually reading it from the deal like I'm supposed to. I'm reading it from the model. But of course, you can always multiply them as well. And we've got 3x squared. And the green x's, so I've got 10 of them. There's 9, and then one more makes 10. And the last is plus the 3. And I'm going to check it up here. That's going to give me 1, and 9 makes 10. And yep, that's the one. Okay, we've got a 4x squared. Let me get rid of this for a second. 4x squared. And we've got 6x. See the 6 green x's there? Oh, darn it. There we go. And we got plus 2. They may have us model some negatives, maybe. We'll see, hopefully. Remember, you always have the option of multiplying these guys as well, which does give me a 6x in the middle. Yep, it's correct. I like to double check every once in a while. All right, we got an x squared plus 4x plus 3. Oh, I always forget to get that. Plus 4x plus 3. Let's see. Of course, that's right. This time we've got 6x squareds, don't we? 6x squareds. Plus there's 9 down here, and 2 more makes 11. Plus 11x. And then we got plus 3. And it's a good idea to check it. 2 and 9 makes 11. I always add those in my head. And the 2x times the 3x is 6x squared, and so on. Okay, we're getting there. Let's see what we got. Okay, we're supposed to multiply these guys. We've got 3x squareds there. We've got 6 and 2 more makes 8x. And we got a 4 at the bottom. There they are. 6 and 2 makes 8, sure enough. Okay, we've got a 6x squared plus 5x plus 1. And we've got a 6x squared plus 5x plus 1, sure enough. We've got a 3x squared plus 7x. There's 6 and 1 more plus 2. And there's good practice there. You can see it. Ooh, a big one. We've got a 9x squared this time. And then we've got 6x, and 6x makes 12x. And we have a plus 4. Check it here. And it is a perfect square trinomial because we squared it. It's a square, isn't it? See that? And that's why we have to double the product, because we always get those two side pieces. Anyway, hopefully you can see the pattern and the connection with the perfect square. Okay, we've got 6x squared. We've got 6 and 3 more makes 9 plus 9x plus 3. And that's the same that I get if I multiply it up there. Got a 9x squared. Okay, another perfect square trinomial. 9x squared. Hopefully you understood what I was talking about when I said that when you multiply a perfect square binomial, remember, this thing is written like this. Do not distribute the squares, because what you'll get is 9x squared plus 1, and you'll totally forget about those green squares. You need to remember there is a middle term, and it comes 3x plus 1 times 3x plus 1. It comes from the 3x and the 3x, and there they are, those green 3x's. Very important that you always get that middle term, and it's always going to be double the product of the factors. And anyway, I'm hoping that makes sense to you. Plus 6x plus 1. Looks good. Another one, x squared plus 6x plus 9. Yep. Maybe 2 more. Oh, another perfect square. Oh, not quite a perfect square. It's a rectangle, isn't it? I mean, not quite on there. That's a 9x squared. And we've got the 6 and 3 more makes 9x. And we have plus 2. And that is, sure enough, 9x is our middle term. And we have one last one, and then we'll have our mastery. This one is a perfect square trinomial. What a perfect way to end. 4x squared plus 4x plus 4. Interesting. 4x squared plus 4x plus 4. And how about 8x? Didn't double it. Can't add today. Don't want to make a mistake on the last one. 4x and 4x makes 8x, doesn't it? And there it is, our final perfect square. And I'll see you back again. Hopefully you'll join me for factoring. I'm really looking forward to that one. Bye-bye, guys. Get your medal.